Hello everyone, welcome to the lecture series of tensor analysis. This is the fourth lecture. In the previous lectures we have discussed about introduction part of tensors, coordinate transformation of tensors and about Einstein summation convention. If you have not seen the previous videos, then please check them out first. In this video we will discuss some questions based on Einstein summation convention. So Einstein summation convention states that if you have some expression, for example aij xj, in this expression here we have two indices I and j. I occurred once and j is repeated index. So the index which occurs once is called free index and the index which repeated twice is called dummy index. And the meaning of repeated index is that you will take summation over dummy index, okay, over all the possible values of j. For example, if you have n possible values, then j will run from 1 to n. So this expression, this term is not one term, it is summation of n terms, okay, j from 1 to n, and we will take summation over the dummy index, the repeated index. And free index is fixed, I is fixed, I can take any value from 1 to n. I could be 1, 2 or n, but just one value, okay. So it is fixed, but j will take all the values from 1 to n, it will take all the values, and I has n choices, but it will take only one value at a time. So this is the Einstein summation convention. Now let's discuss some question based on that. So this is question number 1. Use the summation convention, Einstein summation convention, to write the following and assign the value of n. That means first, by using Einstein summation convention, you have to write this summation in the form of one term, and then we have to find the value of n, okay. So here if you look carefully, the first part, here we have a11 b11, next a21 b12. So first look at the first part of each term, a11, a21, a31, a41. So in each part the second subscript is fixed. Here it is 1, here also 1, 1 and 1, and the first subscript is changing from 1 to 4, okay. So I can say it is like ai1, and I is changing from 1 to 4, so we will take summation, okay, summation I from 1 to 4. So it will be for 1 a11, then a21, a31, a41, so it will cover all the component, okay. Now next b11, b12, b13, b14. So for b, the first subscript is fixed in all four terms, right? So what I can write, b1, and the second subscript is changing from 1 to 4, so we can write I, okay, I from 1 to 4. When you take sum, you will get all the four terms, a11 b11, then a21 b12, the second term, then a31 b13, this one, and then a41 b14. But according to Einstein summation convention, as you can see in this expression, I is repeating twice, so this will be dummy index, then there is no need to write this sigma sign, okay. So we will write simply ai1 and b1i, and as I is repeating index, so that implies that there will be a summation sign, okay. But you have to, okay, but here we have to mention the value of n, okay. So here n is 4, from 1 to 4 it is varying, so the value of n is 4. That's it. Now for the second part, a11 b11, a12 b12. So here first let us take the first component a11, then a12, a13, a14. That means the first subscript is fixed in each term, that is 1, okay. So what I will write, a1i, and for bij you can say B11, B12. Again for B also first subscript is fixed in each term. So what we will write, B1I, okay, and I from 1 to 6, but there is no need to write sigma notation, okay. So we will just drop the sigma notation and we will mention the value of n. We have to mention the value of n, otherwise from this expression you will be able to get that, okay, I is repeating itself twice, that means you have to apply summation, but I from 1 to, so the upper limit you have to mention, okay. So the value of n will give you the upper limit for summation. The lower limit is 1. The value of I will run from 1 to n, so the upper limit you have to get from the value of n, okay. So here for this we have total 6 terms, so n will be 6. Now for this C11 superscript I, so this is not power, right, this is just a, you can say ith component or like that, this is variable, okay. This is superscript. C superscript I22, C33I, C44I. So what we can write, I is fixed in every term. So what is I? I is your free variable, okay, free index. And here we have 1 1, then 2 2, 3 3. So we can write j j, as I is already used, so we will use some other index. So let's use j. So j j, because in every term we have 1 1 2 2, so the same index, okay, the subscript is same, both the subscripts are same. So and superscript is I. So from this expression what you will get, that I is your free index because it occurs once, and j is repeating index, that is dummy index. That means there will be a sum, okay, it is hidden. We do not write when we do tensor analysis or in relative theory of relativity, okay. So while using tensors we write expression in this form, but as j is repeating twice, that means there is a summation. J will vary from 1 to, so you will mention the value of n, it will give you the upper limit for sum. So here we have 8 terms, so n will be 8. So that's it for question number 1. Now the second question, use the summation convention to write the following system. This is system of equation, right? So by using summation convention you have to write this system of equation. Now we have 3 equations and in each equation we have 3 terms, right? So in total we have 9 terms, but you have to convert this system of equation in single expression by using Einstein summation convention. Okay, then state which indices are free and which are dummy indices and fix the value of n. That means we have to find n and we have to write the free index, about free index and dummy index, okay. So let's write, first convert equations, okay. First write each equation in the form of expression, then we will combine them, okay. So first read equation 1. Here we have C11x1, C12x2 and C13x3. As you can see, the first subscript for C is same, 1 1 and 1. So we can write C1, and the second subscript is varying 1 2 3. And when your second subscript is 1, so x has subscript same 1, okay. So second subscript of C and x subscript are same, okay. So let's say here I am putting I, so you will use x, I for x as well, okay, because they are same. Now I, from this expression you can say ki I is repeating index, that means there will be a sum over I, and I will run from 1 to 3, okay. And let us say this is your D1, let us assume this is D2 and this is D3, okay. So D1 is 2, this is D1, D2 is -3 and D3 is 5. So what I can write, first equation, this expression represents the left hand side of this equation and the right hand side is 2, so let us write D1, okay, D1, okay. Now let us convert second equation. So here C21x1, so the second subscript is 2 in each term. So what we will write, C2, and the second subscript, sorry, first subscript is 2 and the second subscript is varying. So let us write I, and same xi is equal to D2, then C3i xi is equal to D3. Now let us combine these three into one expression. So what we can write here, C1i xi then D1. Okay, so if you see carefully, then C's first subscript is matched with D's subscript. Here we have 2, then here we have 2, here 3, then 3. So let us write first subscript as J. Okay, so I am writing J, the second subscript as it is I, xi is equal to dj, because this match with D's subscript. So I am writing like this. Here if you see this expression, then J occurs once, that means J is your free index. Okay, and I is repeating, so it is dummy index. And here on the right hand side we have only one index which is occurring once, so it is again free. And you already we already discussed that free index on both the sides should match. Okay, so if you have some free index on the left hand side, then that same index will appear on the right hand side as well. So here we have J, on the right hand side we have J, that means this expression is well defined. Now look, so here I is dummy, that means there is a summation over I. Okay, let's mention the value of n. So n we have 3 for this part. Okay, so I is dummy, that means there will be a summation run from 1 to 3. So it will give you 3 terms, addition of 3 terms. Okay, now J is free, so J could be 1. So when you put J as 1, you will get the first equation. When you put J as 2, you will get the second equation. When you put J as 3, you will get third equation, right? So this expression is the system of 3 equations. Okay, now come to the second part, aj1x1, aj2x2, aj3. So in every term we have aj, so it is fixed. So let's write aj. Now in superscript you have 1 and x has 1 as subscript, 2, 2. That means if I put I, then here we will also put I. Okay, now I is dummy index, so there will be a sum over I. And what is the value of n? So n is 4. But this expression is for the left hand side. For right hand side, let's write dj. Okay, so j is free index on the left hand side, and on the right hand side we have j as free. So this is meaningful. And I is dummy, so there will be a sum over I from 1 to 4. So you will get all the 4 terms from this expression. Okay, so and I is free, so let's write, because we have to mention which one is, sorry, I is dummy. So you will write I is dummy index and J is free index. Now next, come to third question. Write out explicitly the summations. Now we have to write this summation. This is already given by using Einstein summation convention. For this question you have to expand this expression. Okay, in the previous question we have expansion and we have to write by using Einstein summation convention, but here the question is opposite. We have to find the expansion, right? So for the first expression, ci xi plus yi, so here this is one term and this is second. Okay, so ci and this is xi plus yi. You can assume xi plus yi as zi, so it is like ci zi. So I is repeating twice, so I is dummy index. You cannot count indices like here I1, this is second time, this is third time, so I is occurring 3 times. No, this in this way you cannot count addition of 2 terms. So after adding you will get 1 term. Okay, so it will be like zi or some whatever the result you get. Okay, so I put zi. Okay, so now you will count the indices, and we have already discussed that any index can comes either once or twice, at most twice. No index can repeat more than 2 times. Okay, so otherwise it will be not well defined. So this is now okay. So what you have to, so here I is repeating twice, that means it will be summed over all the possible values of I. If here it is not given, so let us assume, let us do it for n equal to 3. Okay, so I from 1 to 3 Ci Zi, this is what this expression means. Okay, so let's put I equal to 1, so C1 Z1 plus C2 Z2 plus C3 Z3. Now what is Z1? Z1 is x1 plus y1, so let us substitute in terms of x and y. C2 x2 plus y2 plus C3 x3 plus y3. That's it. Now let's do the second expression. This is for first. Now for second, what is written? Cj xj plus ck yk. So it is addition of two terms. In both the terms, in the first term we have j index, okay, and it is dummy, and in the second term k is the index and it is also dummy because it is repeating twice. That means there will be a summation over j and there will be a summation over k. So here for this question we will take the same value of n. So what it means, Cj xj, but here will be a sum j from 1 to 3, and for this ck yk k from 1 to 3. Now let us expand it. C1 x1, C2 x2, C3 x3, then we will have C1 y1, C2 y2 plus C3 y3. Now if you see both the results, then they are same. Like here C1 x1, so you are getting C1 x, then C1 y1, okay, so C1 y1, C2 x2, this one, C2 y2, so this is C3 x3 and C3 y3. So all the terms are same. Okay, so basically if you multiply, if you use distributive law, right, so Ci xi plus yi, so by distributive law what you can say, this will be Ci xi plus Ci yi. Okay, you can use distributive law only when the index are same in the inside the bracket. Okay, if the index are same, then we will use the distributive law, otherwise it will be not well defined. Okay, so it will be Ci xi Ci yi. So Ci xi, here what is written, Cj xj, and here Ci yi and here Ck yk. And as you know that dummy index you can replace it with any other index. Okay, so you can say for the first term they replace I with j, and for the second term they are replacing I with k. So that's why both the terms are same, because after expanding it you will get this, and these both are same. Okay, so let's move to the other question. In fourth we have n equals to 3 and we have to expand this expression. Okay, so q, value of q is aij xi xj. So in this expression I and j both are dummy index because both are repeated, so both are dummy indices. Now what it means, it means you will take sum over I and sum over j. So let's fix j and let's take sum over I one by one. Okay, what it means, this means j from 1 to 3 and I from 1 to 3. Okay, aij xi xj, because I and j both are dummy index, so there will be summation over I and over j. So this is an example of double sum. Okay, double sum. So when double sum comes, if you have two dummy indices, then there will be a problem of double sum. Okay, so how you will expand? So let's first keep j fixed and vary I. Okay, so I first take 1, so you will get a1j x1 xj, then a2j x2 xj, then a3j x3 xj. For next, let's vary, let's put value of j. So first let us put 1. So when you put j as 1, a11 x1 x1, then a21 x2 x1, then a31 x3 x1. Now put j as 2. So in all three terms you have to put j as 2. Okay, so a12 x1 x2, a22 x2 x2, then a32 x3 x2, then we will substitute j as 3 in all the three terms. So a13 x1 x3, a23 x2 x3, and a33 x3 x3. So first when you put j as 1, so you will get 3 terms, then for 2 again 3, and for 3 again 3. That means you will get 9 terms, right? So here we are getting 9 terms because we have two sum and both the sums are from 1 to 3. So 3 times 3 we will have 9 terms. So this is the expanded form for cube, right? So this is an example of double sum. Let's move to the last question. Use the Einstein summation convention to write the following and state the value of n. Okay, necessary in each case. So for the first part, a11 b11, then a21 b12. So here a11, here a21, then a31. So in the first three terms, age second subscript is same, 1 1 1. So I can write 1 as second subscript, and the first subscript is moving 1 from 1 to 3. So let us write I. And for b, 1 1, then 1 2 1 3. That means the first subscript is same. So let me write 1, and the second subscript is varying. So I am writing ai1 b1i for the first. As you can see, I is dummy, that means there will be a sum from 1 to 3. So by this expression you will get summation, these first three terms. Okay, now let's combine these three terms. So as you can see, A's second component is 2, A's second subscript, and first is varying. So what I will be write ai2, and for b the first subscript is 2 and the second one is varying, so b2i, and I is dummy, so there will be a sum from 1 to 3. So you will get these three terms. In the same way we will write ai3 and b3i. Okay, so that's it for this. So this is the expression. Okay, now can we combine these 3 into one term? So here ai1 b1i, then ai2 b2i. Yes, we can combine again aij bji. Okay, now here we have j and I both dummy index. Okay, so there will be sum over j and over I. So first let us go back. Okay, so how you can prove that these both are same? So j is dummy, that means you will take sum over j. So when you put j as 1, so you will get ai1 b1i, so the first term. Then you put j equal to 2, you will get second. When you put j as 3, you will get third term. Now for the first, I is dummy, so you will put I as 1 2 3 and then add them, so you will get first three terms. From this you will get second, this three terms, and then the last three terms. So this is the correct. So the 9 terms you can write it into only one expression. Okay, so Einstein summation convention, it simplifies your things. Okay, simplify you in simplified way, you can write the big expression into very smaller one. For the second term, for the second part, what we have, g11 superscript 1, then g121. So I have written here, this is the second part. So what I have done, I am writing here, as you can see, g, here we have 2 subscript 1 1, 1 2 2 1, then 2 2, then here we have 1 1 again. Okay, so this first term and this term have same subscript. Okay, so I am combining these two, g12 the second term, and here also we have this term with same subscript. Superscript is changing but the subscript is same. So what I am doing here, the terms which share same subscript, I am combining them. So first I am writing the terms with the subscript as 1 1, then I am writing the terms with subscript as 1 2, then 2 1 subscript terms, and then 2 2 subscript terms. Okay, now I am combining these two terms. So as you can see, 1 1 is fixed in both, so g11, and 1 to 2 it is changing. So if I put I here, okay, so it will give you this expression? No, because here I occurs once, I is occurring once, okay. So I is your free, and if it is free index, then there will be not a summation, okay. So you cannot get these two terms. So this is not good way to, this is not right way to do it, okay. So what we will do, we will multiply it with some constant. So first let me introduce some constant. Let ci equal to 1 for all I, okay. I am introducing some constant ci. Now what I will do, I will multiply each term with this ci. Its value is 1, so it will not change the result, okay. So what I am doing, I am writing again g111 c1, then g112. So if its superscript is 1, then you will multiply that term with c1. If its superscript is 2, then you will multiply that term with c2, okay. So here g121, so you will multiply it with c1, g212, so here c2, then g21 c1, g212, then c2, then for g22 this is 1, so you will put c1. When you have superscript as 2, you will multiply it with c2. So both the expression are same, because c1 and c2 are for I 1 and 2. For both 1 and 2, c1 and c2 are 1, okay. Now let us combine these two. So how you will combine? g11 I ci, because the superscript is same as c's subscript, okay. So now I is repeating index, so there will be a sum. So when you take sum over I, so when you put I as 1, you will get the first term. When you put I as 2, you will get the second term. So after multiplying the constant, you are getting the correct answer. For now combine the other two terms. So how you will combine? g12 I ci, then for these two terms g21 I ci, then g22 I ci. Now ci is common, so let us take common, okay, and g12 I, g21 now can we combine these four terms? So yes, we have. Now look, the subscript of g, the superscript is fixed in every term, but the subscript is here 1 1 1 2, that means the second subscript is changing. Here 2 1 and 2 2, that means the first subscript is also changing from 1 to 2, and the second subscript is also changing 1 to 2, that means both the subscripts are changing, okay. So what I will do, I will use two notation, I and j, okay, and here I. So I is already used, so we cannot use I. Let us use some other index, j and k, okay. So you cannot repeat the index, okay. So I is already used, so you will use some other index, j, k I am using. Now j and k, because you have to vary, when you will get all the four terms, when you will take summation over j and over k, that means you have to make j and k as dummy index. So what you will do, you will multiply with cj and ck, cj and ck. So j and k will vary from 1 to 2. So you know that c1 and c2 both are 1. You have already defined, okay. So I am multiplying this with cj, ck, and outside we have ci. So now j is repeating and k is repeating. That means there will be summation over j and k. So when you take j from 1 to 2 and k from 1 to 2, so j from 1 to 2, you will j and k from 1 to 2, so you will get these four terms, okay, and ci is outside. Then I is repeating twice. Inside bracket we have one I, and outside we have the other I, okay. So there is also I is also dummy, so you have to take summation. So in this way you will get all these 8 terms. So this is the final answer for this, and n is here, n is how much? 2, right? I from 1 to 2. N is not number of terms, but the value of I, means from where to where I is varying. So from 1 to 2, so the upper limit about I is the value of n will tell you the upper limit of I. So that's it for this video. If you find it helpful, then please hit the like button. If you are new to channel, then please subscribe my channel. Thanks for watching.